right, guys, so we're gonna look at some word problems, but don't worry, I'm gonna walk you all the way through them. Okay, so here's our problem. At the beginning of spring, Taylor planted a small sunflower in her backyard. When it was first planted, the sunflower was 25 inches tall. The sunflower then began to grow at a rate of 2 inches per week. How tall would the sunflower be after 7 weeks? How tall would the sunflower be after W weeks? Okay, so I know you probably half stopped listening to me through this problem because either you don't want to listen to word problems or you don't care about flowers or both. I probably really lost you when I talked about W weeks because that's not even a number. So let me walk you through what this is talking about. Here's what we're talking about. A flower's growing. That's it. Okay, so let's not make a big deal about this, just how tall did the flower get? Now we can figure out part of this without doing any math. The part about W weeks, that just means write an equation. So with my amazing artistic skills here, I've drawn us a little picture. Okay, so what we've got is we have our beautiful little sunflower right here when it's starting at 0 weeks. 0 weeks, yeah, that's because we just planted it right now. And it is 25 inches tall. Every single week, it's growing 2 inches. So every single week, 2 inches, 2 inches, 2 inches, 2 inches, 2 inches. And the question is, how tall is it after 7 weeks? Hey, you guys, you see something cool? It's a line! What? No wonder we've been doing lines for so long. So this is just a slope-intercept problem. And we just need to know what does it change by and what does it start with. So let's come back to our problem. All right, so we've got 25 inches tall. We've got a rate of 2. All right, so when we write our equation, we're gonna have 2 at a rate of 2 inches per week, so 2x, that's 2 inches per week, plus 25. Oh my gosh, we are super geniuses. That's our equation. Okay, well, the last part we have to do is just what was it after 7 weeks? Well, in that case, all we do is take 7. 7 is our x value. That's what's changing every single week. And really, so the word problem says to use W. I used X. It means the same thing. If we're doing it in the computer might want you to say W, but it means the same thing. So all I need to know is 7. So if I go, okay, well, 2 inches for 7 weeks. Okay, well, that's going to be 14. Oh, I'm running out of space. Let me bring it back up here. So if I have, boop, 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 boop. If I have 2 times 7, that's going to be 14 inches, plus the 25 inches that it was already at, it's going to be 39 inches tall after 7 weeks. Okay? So really all you need to remember here when you're looking at word problems is where did it start at? What is it changing by? That's your line, and then you can just put it into your equation. All right, so let's try another word problem that has more than a couple sentences, but the change is that something is decreasing. Okay, so here we go. At the end of a snowstorm, now I know that's not common in Georgia. Snow is when cold things fall from the sky. Ethan had 11 inches of snow on his lawn. The temperature then increased and the snow began to melt at a constant rate of 1 inch per hour, which means the snow's melting. Assuming no more snow was falling, how much snow would Ethan have on his lawn 2 hours after the snow began to melt? And how much snow would Ethan have on his lawn after T hours of snow melting? Guys, this is the part I need you to get over. I hate those sentences because that doesn't make sense. What are T hours? What's T hours? That just means X, something we don't know. It's part of the equation, okay? So no matter how many hours after the snow, T, that's what we're trying to find. So if we take a look here, okay, I know that I had 11 inches of snow. That's almost a foot of snow. That's some craziness right there. All right, so that's my y-intercept. That's my starting value. That's where I'm starting at. Start. All right, then what's my rate? Okay, well, 1 inch per hour, but am I getting snow? No, I'm losing snow. It's melting. So my slope is going to be -1. Boop, boop. negative 1. So when I write my equation, I'm going to have y equals negative 1. That's my negative 1 inch because I'm melting for every t hours. So I'll use t because it's t. But I started with 11. So that is my equation. Do you see how these numbers right here, this 11 right here, goes with the 11 that I started with? And this negative 1 right here goes with the negative 1 that's melting. And then the x and y are just your slope-intercept. So that's after t hours. The question here was asking about 2 hours. Guys, you can do this part in your head. And if you can't, then we need to really think about subtracting here. If you have 11 inches and 1 inch melts per hour, you start with 11. After 1, you'd have 10. After another hour, you'd have 9. You just subtracted out 2. Okay, so I didn't even do algebra there. I just thought through this. So after 9 hours, after 2 hours, you would have 9 inches left. See, they're not so scary. All right, so we've got one last problem to look at, and this is when I actually have a negative starting value, which is kind of weird if I'm just saying it, but take a look at what this problem is. Ryan went to the store to buy some apples. The price per pound of the apples is $4.25 per pound. Okay, so 1 pound, $4.25. He has a coupon for $2 off the final amount. So he goes to ring up and $2 off. With the coupon, how much would Ryan have to pay for 5 pounds of apples? Also, write an expression for the cost to buy p pounds of apples, assuming at least 1 pound is purchased. That's the part I know you guys always tune off at. That's fine. It's just saying write an equation. Okay, write an equation, and how much does 5 pounds cost? We can figure this out. So as we pull apart the pieces we need out of all of these words, we got apples. Bam, $4.25 per pound. Cool. As soon as I see $4.25 per something, I know that's my variable. So in this case, I am buying peas. So $4.25 p. $4.25 per pound. Okay, halfway done. Now, if I don't have a coupon, it's $4.25 per pound no matter how many pounds I buy. But I have a coupon. It's $2 off the final amount. So it's not like per pound, it's just straight up however much this cost minus $2. There's our equation. So $4.25 per pound, take away the $2 for your final amount. And so that would be our expression. Ooh, fancy expression. But now let's actually solve it with what it was asking, which is if I wanted to buy 5 pounds. So $4.25 times 5 pounds minus $2. So off camera, $4.25 times 5 pounds is $21.25. So without the coupon, I'd have to spend $21.25, but I have a coupon. So if I take away $2 off that will give me $19.25. I'm just writing straight over this problem. $19 worth of apples for 5 pounds. So hopefully you really like apples or you're gonna make a lot of apple pies.